The transformations of cosecant and secant work very similar to the transformations of sine and cosine. We'll start off by identifying A, or our vertical stretch, what we're multiplying before the function. Our amplitude is 2, absolute value of 2. In this case, our B value is 1, what we're multiplying by the x, so our period will remain 2 pi. D, we are shifting it up 3. Notice that plus C is not in parentheses with the x, so it is not a phase shift, it's a vertical shift. Our left endpoint will be 0, and our right endpoint will be 2 pi, because we do not have a change in period or a phase shift on this one. That makes life easy for scaling our x-axis by pi over 2, pi, 3 pi over 2, and 2 pi, just like our parent function, and reflecting that over off to the left. To scale the y-axis, we need to take into account that vertical shift. So we're going to go up 3, that's our new principal axis. And then we have a vertical stretch of 2 from there. Sine function starts at 0, goes up to its maximum, back to 0, down to its minimum stretch of 2. Make sure you're only going 2 under that principal axis, and back to 0. Reflecting off to the left, down to its minimum, 0, maximum, 0. The first thing we need to getting our cosecant function graphed is to identify where the sine function is 0, and that is along the new principal axis. And then remember, none of these transformations were flipped. All of the transformations remain the same. So we're simply going to make those parabolas connect to the maximum and minimum values of our sine function. And that is our cosecant function with the given transformations. Last example, we'll take a look at a secant function. A, again on this one, is 2, so that's our amplitude. B is still 1 because we're multiplying that x by 1, which means our period is still 2 pi. This time we have a vertical shift down 4, and we do have a phase shift, so we'll set x plus pi over 2 equal to 0 to get our left endpoint, and x plus pi over 2 equal to 2 pi to get our right endpoint. Subtracting pi over 2, we have a left endpoint of negative pi over 2. And adding pi over 2 to 2 pi, getting that common denominator of 2, 2 pi becomes 4 pi over 2 minus pi over 2, which gives us 3 pi over 2. Starting at our left endpoint, nice enough, it matches with the scale for our period, which would be pi over 2. And we need to go out to 3 pi over 2 to get to our right endpoint. We're going to need a little bit more room off to the left because we need 1 full period, or 4 scale marks, away from our left endpoint. So we'll just extend that x-axis to get out to negative 5 pi over 2. We had a vertical shift down 4, and then we had a vertical stretch of 2, so we need to go down to negative 6. Sketching in that principal axis at negative 4, which gave us that vertical shift. And then we can graph our cosine function. Remember the phase shift, we're starting at negative pi over 2, and cosine starts at its maximum, back to 0, minimum, 0, maximum. And the same thing off to the left. Again, identify those asymptotes where the cosine function equals 0, or where it hits that principal axis. Find those maximum and minimum points and sketch your parabolas. With cosine functions starting at its maximum and ending at its maximum, we end up with this weird shift with the secant function, so that when you scale it by a full period of cosine off to either side of the phase shift, you'd end up really with half a parabola on either side. I just go ahead and finish the parabola on one side, and then I don't need to make another one on the other side. As long as you have 2 full periods of your function, meaning 2 parabolas opening up and 2 opening down, then you're good to go.